welcome back to my channel. I hope you are revising chapter 1 for your class 11th final exams under CBSE board. I have already posted the first few videos of this chapter. The last one was about atoms, molecules, molecular masses, Avogadro number, and Dalton's atomic theory. And today I'm going to discuss stoichiometric numericals and limiting reagent. And the next one is going to have all concentration terms that would complete the chapter. I hope you're working hard, you're making use of this time. These videos will help you reconnect to the basic topics once again just before your exams. Stay geared, children. Come out of your comfort zone. Exams are fast approaching. So let us get on with the next one. All the best. We are going to start now with stoichiometry. What is stoichiometry? Stoichiometry involves questions based on balanced chemical equations. So the first question to understand this concept is chlorine is prepared in the lab by treating manganese dioxide with aqueous hydrochloric acid. So the equation is also given 4 moles of HCl plus manganese dioxide to give water MnCl2 and chlorine. Grams of HCl react with 5 grams of manganese dioxide. This is an NCERT exercise question. Atomic mass of manganese is given to you as 55 U. So just recalling the points we have done in the last video, 55 U means we are talking about mass of one atom of manganese. So molecular weight of manganese dioxide is 87 gram, and this is gram molecular weight since it's mentioned in gram, and this stands for Avogadro number of molecules of manganese dioxide, just helping you recall what we did in the last video. So according to this equation, 1 mole of manganese dioxide, which means 87 gram of manganese dioxide, is reacting with 4 mole of HCl. 1 mole of HCl weighs 36.5 gram. So 4 into 36.5, that is 146 gram of HCl. According to the equation stoichiometry, 87 gram manganese dioxide reacts with 146 gram of HCl. So 5 gram of manganese dioxide will react with how much? This is simply a unitary method. 146 divided by 87 into 5. This gives 8.4 gram of HCl. So we move on to the next question. This is simple stoichiometry. That is, in a balanced chemical equation, any one of the components is given and another one is asked to be calculated. So we move on to the next. Liquid benzene burns in oxygen according to the given balanced chemical equation. The question asked is how many liter of oxygen at STP is required for complete combustion of 39 gram of liquid benzene. So again, we have the balanced equation. We are supposed to calculate volume of oxygen at STP, and the new STP is 1 bar, 273 Kelvin temperature, and at this 1 mole of every gas, 1 mole of every gas occupies a volume of 22.7 liter, right? We also call this as molar volume. Clear? So now let us look at the solution. In this balanced chemical equation, we understand 2 into 78 gram. 78 is the molecular mass of benzene. 12 into 6 plus 6, 78. 2 into 78 gram of benzene requires 15 moles of oxygen, which means 15 into 22.7 liter of oxygen gas. Now, 2 into 78 gram of benzene requires 15 into 32 gram of oxygen gas, right? If I want to talk in terms of mass, if I want to talk in terms of number, I would say these many molecules of oxygen gas. I'm just telling you, we don't need all this for this question. I'm telling you for you to be able to relate a link. Or 15 into 22.7 liter of oxygen gas. Clear? So Depending on what is asked, since we have been asked volume of oxygen at STP, so we are going to use this last relation. So proceeding with this, 39 gram is going to combine with how much? Simple unitary method, 15 into 22.7 upon 2 into 78 into 39, and we get the answer in liter, 85.125 liter. We move on to the next. The weight of KMnO4 required to completely oxidize 0.25 moles of ferrous sulfate in acidic medium. And the options are given to us. Again, we are simply going to use up the stoichiometry. Now, the balanced chemical equation might or might not be given. If you are doing this for JEE or some competitions like NEET, etc., in that case, they might not give you the balanced chemical equation. There, what is the best way to do? Convert this to ionic equation. Just take the iron permanganate ion. From here, take the iron ferrous ion. This is a redox change, right? And then they say acidic medium, just put H plus. You must know the products in acidic medium. Permanganate ion produces manganese ion and ferrous produces ferric. Along with that, water is formed. And since we only need this stoichiometry to solve this numerical, our concern is not to have the complete balanced equation. What could we do here? We could simply calculate n factor of each of these. What is n factor? The number of electrons lost or gained by a species during a redox change. So n factor of permanganate ion is going to be 5 since 7 is changing to 2. And the n factor of ferrous is going to be 1 because ferrous is changing to ferric. And one of the ways to balance equations is I put 1 here and 5 here. Crisscross the n factors, you get the balanced equation. We don't even need the moles of HCl because that's not what is asked, right? So they've asked you weight of KMnO4 required to completely oxidize 0.25 moles of ferrous sulfate. So what are you going to relate? You can just understand that 1 mole of KMnO4 is required for 5 moles of ferrous sulfate. And you can just go and proceed with the reaction. Okay. Here we have a proper complete molecular balanced equation. And this stoichiometry is also 2 and 10. That is a ratio of 1 is to 5. Clear? Now, let us proceed with this. The balanced molecular equation tells us 2 into 158 moles of KMnO4 combines with 10 moles of ferrous sulfate. Or I could have written 158 grams. This is gram. This is the molecular mass of KMnO4. 158 gram of KMnO4 requires 5 mole of ferrous sulfate according to the ionic equation that we just balanced. Either of the two is going to give you the same answer. So just solving this further, we are going to get 7.9 gram as the answer. 2 into 158 uses 10 moles of ferrous sulfate. So for 0.25, how much is going to use? So unitary method, 10 moles for 2 into 158 gram. This is moles of ferrous sulfate and this is KMnO4. So 0.25 moles is going to react with how much? This upon this into this. That's what we are doing. And when you solve, you get your answer as 7.9 gram. This is simple stoichiometry. One more question. X gram of calcium carbonate was completely burnt in air. The weight of the solid residue. Now, solid residue means calcium oxide because carbon dioxide being a gas will escape off. This was solid. Solid carbon dioxide being a gas is going to escape off. So we know the molecular mass of calcium carbonate is 100. Molecular mass of calcium carbonate is 100. Calcium oxide is 56. And since 1 mole of both are involved, so we know 100 gram of calcium carbonate gives 56 gram of calcium oxide, also 44 gram of carbon dioxide, but that escapes off being a gas. So our question asked is X gram of calcium carbonate was completely burnt. So we simply have to calculate X. The answer is going to be 50 gram. This is a very simple direct question. Since 56 gram of calcium oxide is coming from 100 gram, so 28 gram, which is half of 56, will come from how much? 50 gram. These are examples of simple stoichiometry for your school level. Now, coming to the concept of limiting reagent, children find this a little difficult. So, I'll be giving you two methods for this, children, the proper elaborate method, and then I'll give you one shortcut. At the end of the video, I'll be explaining one shortcut. If you understand the shortcut, you can use that. If you cannot, use the longer method. Shortcuts should never be used in exams unless and until you practice them well in your practice sessions, right? So first, to begin, what is the limiting reagent? Limiting reagent is the reactant which is totally consumed in a chemical reaction, or basically the reactant which is present in lesser amount, which is present in lesser amount, and it gets consumed after some time, and after that no further reaction takes place, whatever may be the amount of the other reactant present. In simple words, I can say the reactant which is present in lesser amount and which limits the extent of reaction, which limits the extent of reaction. What is the meaning of limits the extent of reaction? Which decides how much of product will be formed. That is called as the limiting reactant. Uh, Now, before I start with this numerical, if I just give you one simple example, I have A plus 2 moles of B to give C. Supposing I have this reaction and I tell you I took 1 mole of A and 3 moles of B to begin with, how much of C will be formed and which is the limiting reactant? So, how are we going to decide? We know 1 mole of A requires 2 moles of B. So, B is more than required, right? So, 1 mole of this will completely react, and out of this, it will use only 2 moles, which means 1 mole of B will be left unreacted because we would not have more A to combine with this. Hence, we will decide that A is the limiting reactant. So 1 mole of A completely gets used up. It uses only 2 moles of B out of this, and we get the product form C. How do we decide how much of C is formed? We decide it on the basis of limiting reactant. Since 1 mole of A gives 1 mole of C, so here also we had only 1 mole. So we will say the product formed is going to be 1 mole of C, right? Similarly, if I give you another some example, A plus 2 moles of B to give C, and this time I tell you that I have 2 moles of A and 3 moles of B, and I ask you the limiting reactant, and I ask you to answer which out of the two is limiting and how much of C is formed. So this time, what are we going to do? We know 2 moles of A will require 4 mole of B for complete reaction, but we do not have 4 mole. We have just 3 moles of B. So B this time is going to be the limiting reactant, and 3 moles of B will use how much of A? We know 2 moles of B uses 1 mole of A. Hence, 3 moles of B is going to use 1 by 2 into 3, that is 3 by 2, that is 1.5 mole of A. So, what will happen at the end? We will have 1.5 mole of A used, which means zero point 0.5 mole of A will be left unreacted because we took 2, and 3 mole of A will all get used up. So which is the limiting reactant? B. B gets completely used up in the reaction. No B is left back. Okay, why? Because this extra zero point 0.5 mole of A would require 1 mole of B, and we don't have that 1 mole of B extra. So limiting reactant is B this time, and we understand 3 moles of B is going to give how much of C? 1.5 mole. Why? Because every 2 moles of B leads to 1 mole of C. I hope this point is clear. What is the difference between simple stoichiometry and limiting reactants? Simple stoichiometry means if I tell you that I have 1 mole of A, tell me how much of C is formed. It's so simple. You will say 1 mole of A will give 1 mole of C. If I tell you I have 2 moles of B, how much of C will be formed? You will simply say 2 moles of C, right? But if I just tell you I have 4 moles of B, how much of C will be formed? So you know 2 moles of B gives 1 mole of C. So 4 mole is going to give 2 mole. This is simple stoichiometry. Any one component is given and one is asked. Limiting reactant means when both are given, but both are not given in the exact stoichiometric proportions. One is less and another is in excess of what is required. So then we are going to use this concept that we are studying. Let us take up the next numerical. How much magnesium sulfide can be obtained from 2 gram each of magnesium and sulfur by this given reaction? So you have to tell me which is the limiting reactant. Calculate the amount of one of the reactants which remains unreacted. You can even pause the video, children, go through the answer yourself, and then just check the answer. Right? So, what are we going to do? Let us first express each quantity in moles. It just makes it easier. You can do it by masses also. So, 2 gram by 24 is the number of moles of magnesium. I've used 24.3, but 24 can also be used as atomic mass of magnesium. This is moles of magnesium, and these are the moles of sulfur. Again, for sulfur in exams, you can use just 32, the rounded off value as well. Right? So we get moles of magnesium and moles of sulfur, but the equation tells us 1 mole of magnesium requires 1 mole of sulfur. But here we don't have the same number of moles of both. This is lesser, this is more. Hence, this will be the limiting reagent. Okay, so which is going to be left unreacted? Magnesium will be left unreacted. How much will be left unreacted? Just take a difference of these two values. These many moles of magnesium will be left unreacted. Right? It's very simple, children. Both are required in similar amounts, right? So the one which is lesser is the limiting reactant. The other one will be left unreacted. So limiting reagent is sulfur. And we are going to calculate the mass of magnesium sulfide formed based on sulfur. These many moles of sulfur were present into molecular mass of magnesium sulfide. Why? Because the equation was magnesium plus sulfur to give magnesium sulfide. So if 0.0624 moles of sulfur are present, they will give 0.0624 moles of magnesium sulfide, and the mass of molar mass of magnesium sulfide is 56.4. So we're going to multiply and we get this much of magnesium sulfide. So moles of magnesium left unreacted. I take the difference, and these are the moles of magnesium left unreacted. We move on to the next question. So this is only if we want the mass also. I've multiplied with atomic mass of magnesium. So this is the next question. Question is question similar to one given in the NCRT exercise. 50 kg of nitrogen gas and 10 kg of hydrogen gas are mixed to produce ammonia gas. Calculate the ammonia gas formed and identify the limiting reagent in the production of ammonia in this situation. Clear? So what are we going to do for this question? We are simply going to write down the balanced equation. This is the balanced equation, and we know the stoichiometric proportion of nitrogen, hydrogen, and ammonia is 1 is to 3 is to 2. Clear? So how are we going to proceed with this? We are first going to calculate number of moles of each. This is the proper longer method. Calculate number of moles of each. How do we calculate number of moles? We have been given 50 kg of nitrogen gas. We multiply it with 1000. Why? In order to convert it to gram. Because you know 1 kg is 1000 gram. Clear? This is the stoichiometric proportion, and I divided by 28, which is the molar mass. So basically, what have I done? It is 50,000 gram is the given weight of nitrogen dividing with the molecular mass 28. So I'm going to get the number of moles of nitrogen gas. And now this is number of moles of hydrogen. Number of moles of hydrogen, what are we going to do? We've been given 10 kg. 10 kg means 10,000 gram of hydrogen. Molecular mass of hydrogen is 2, so 10,000 by 2, we're going to get these many moles of hydrogen gas. Right? According to the balanced equation, 1 mole of nitrogen gas gives 3 moles of hydrogen gas. So these many moles should give how much? We can calculate. Simply multiply this with 3. We're going to get the number of moles of hydrogen. 1 mole of nitrogen requires 3 moles of hydrogen, 17.8576 moles. From where did we get this value? If you look at this previous number, we have these many moles of nitrogen and these many moles of hydrogen. This is what is available to us, right? So now these many moles of nitrogen are going to require 3 into these many moles of hydrogen. And this number will come out to be equal to this. This quantity is more than the number of moles of hydrogen that are provided to us. So hydrogen is less than required for complete reaction with nitrogen. Yes. What is the complete amount of hydrogen required for complete reaction with the given amount of nitrogen? This is 5.667 into 10 to the power 3 mole, right? So what will we say? Since hydrogen is present in a quantity less than required, so dihydrogen is a limiting reactant. Okay, so now number of moles of hydrogen are 4.96 into 10 to the power 3. According to this equation, 3 mole of hydrogen give 2 mole of ammonia. This is not 4.96 children, this is 5. This is the number of moles of hydrogen we have. So since number of moles of hydrogen are these many, according to this equation, since number of moles of hydrogen are 5 into 10 to the power 3, according to this equation, 3 moles of hydrogen will give 2 mole of ammonia. So 5 into these many moles of hydrogen should give these many moles of ammonia, right? Since hydrogen is a limiting reactant, we are deciding a product on the basis of hydrogen gas. So we move on to, I'm giving you now another shortcut method to solve the same question, children. If you understand it, if you like it, you can use it. But you really need to practice questions with this. What do we really do in this case? This is the given gram of hydrogen and nitrogen, given quantities. Now we are going to divide this given quantity by the stoichiometric quantity in the same unit as the numerator. Stoichiometric quantity in the same unit as the given quantity, right? So stoichiometric means this is 1 mole. 1 mole is going to weigh 28 gram. So I'm dividing this 50,000 by 28. Similarly, the stoichiometric quantity for hydrogen given to us is the given quantity is 10,000 gram and the stoichiometric quantity is 6 gram. How? 3 moles into 2. 6 gram is the stoichiometric proportion of hydrogen. So I'm dividing 10,000 by 6. And this side, x gram of ammonia. Ammonia is asked. We have to calculate how much of ammonia is going to be formed. So I'm going to divide this by the stoichiometric quantity, that is 2 into molecular mass of ammonia is 17 gram. So 2 into 17, I get 34 gram. Clear? I find out these calculations, these solutions. I get this. Out of these two, whichever comes out to be smaller is going to be the limiting reactant. This number comes out to be the smaller. This will be the limiting reactant, and I simply equate this unknown quantity with the limiting reactant component, and I get X to be equal to these many gram. This is a simpler method, a quicker method. If you understand, you do it. Also, what if I want to calculate what mass of nitrogen is left unreacted? I will simply take a difference of these two. I get 119. And now, if I want to calculate how much of nitrogen is left unreacted, X gram, that is the amount of nitrogen left unreacted, again divided by the stoichiometric proportion 28, and I equate it to this number 119, I'll be getting the amount of nitrogen left unreacted. Okay, it is the same as what we calculated by the other method. Clear? I'm leaving one question as homework. You can try it by the shortcut method or by the longer method, and I'll post its answer in the next video. So the question is 2 gram of hydrogen is taken in a container with this much of oxygen gas at these conditions. Identify the limiting reactant. How much of excess component is left unreacted, and what is the number of molecules of water formed as a product? This is the equation given. Answer will be next. Stay tuned, children. Please do like, share, subscribe. Sharing is going to help so many more children who are waiting for that last moment revision. And I really feel these videos will help you a lot. And in case they're not helping you and you want them to be better, please comment below. Keep working hard and just give it a good shot during the finals. Stay blessed, children. I close the class.